Other parts of the oil industry where science is important. The waters of our southern coast are said to be some of the most dangerous and unpredictable waters in the world. Even when the drilling rigs and production platforms at sea are anchored or bolted to the seabed, they still need to be served from the land with food supplies, drilling equipment, and spare mechanical parts. The job of a seagoing captain is therefore very important. As a captain or a chief engineer on one of the drilling rigs or ships servicing the oil industry, you will need to know a lot about the sciences of engineering and navigation. This will mean quite a lot of extra study after you leave school, but it may not be necessary for you to go to a university. Then there are the helicopters, which carry the crews to the rigs. To become a helicopter pilot, you will have to put in many hours of practical flying and theoretical work. And perhaps the most difficult job of all is working underwater as a diver. You have to be extremely fit and also have to spend long hours of study to ensure you remain safe. It's not all muscle. You do need to know your science and be able to study well. What part do engineers play? Engineering plays a major role in the successful development of any oil or gas field. In South Africa, we've not found any really big reservoirs of oil and gas under the land, but our geoscientists have found oil and gas under the ocean floor about 100 kilometers south of Mossel Bay, and there is potential for a lot more. This is where we've built a giant platform towering 114 meters above sea level and extending 105 meters below, where it is bolted to the Earth's crust. This platform houses the equipment needed to extract natural gas and condensate from the FA gas field and is connected to the shore by two long undersea pipelines. One pipeline is for gas, the other is for condensate, a light oil that condenses from the gas when the pressure is reduced. We also have a floating production platform at the Oraby field not far away, which controls the flow of oil to the surface, where it is loaded into a tanker and ferried to the refinery at Cape Town. Both these platforms, as well as the drilling rigs which drill the holes in the first place on the ocean bed, are giant engineering structures. They're complicated structures too, because everything has to be fitted together in a very small place. Designing and making these platforms and putting them in place involves a lot of very skilled work by engineers. It involves a lot of scientific work, lots of theoretical problem solving, and statistical planning. Geoscience and the environment. Drilling into the Earth's crust to bring out oil and gas can be very harmful to the environment if it is done without proper planning. Digging up the top soil to lay piping, placing large metal constructions on the ocean bed, risking leakages at the wellhead when drilling, or spillages from tankers when transporting at sea. All of these can have extremely harmful effects on plant and animal life. So before any oil and gas exploration can take place, there has to be a long period of in-depth research and planning. This is called an environmental impact study. Scientists in the oil and gas industry are constantly at work researching new ways to make the discovery and transportation of petroleum as safe as possible. Hydrocarbons in your everyday life. Oil and gas make the world go round. Oil was once called black gold, but today its importance goes beyond money. Oil and gas help shape the world we live in and are the raw materials for everyday life. How do we refine petroleum? Once hydrocarbons, known as petroleum, have been found and brought to the surface, they have to be treated so that they can be turned into the useful products we use in our daily lives. We do this at a place called a refinery. There are over 900 refineries in various parts of the world today. Although we call oil and gas petroleum or hydrocarbons, there are many different ways in which the hydrogen and carbon are connected chemically. Exploration and production. Before we can bring petroleum to the surface, we have to first locate it in its reservoirs. Since we can't physically see what's under the Earth's crust, we've had to develop other methods of looking. We call these other methods remote sensing. One of the methods developed by the geoscientists is called seismology. Different rock layers reflect sound and other shock waves in different ways. We can form some sort of picture of what lies beneath. These pictures are called seismic profiles, and geoscientists and geophysicists study them to find the most likely place where a petroleum trap might be. It is then up to the engineers and geologists to decide where to drill into a trap, for it is a very simple rule that you cannot find oil and gas without drilling holes. So by sending sound waves through the Earth's crust and recording the speed and intensity at which they reflect back, we can form some sort of picture of what lies beneath. These pictures are called seismic profiles, and geoscientists and geophysicists study them to find the most likely place where a petroleum trap might be. It is then up to the engineers and geologists to decide where to drill into a trap, for it is a very simple rule that you cannot find oil and gas without drilling holes.